Hello everyone, we're back over here in question 11. It says, which of the following is the domain of y equals x minus 2 over the quantity of the square root of x squared minus 9? And I want to find the domain, which means these are the x values here, okay? So normally what we've been doing is we've been graphing them out. The problem is we can't graph this over here by hand. Notice it is not the same thing. So this here is not the same thing as something like this. These are different. If you notice, because it's on the denominator here, and also this x minus 2 changes it. So this is what we call a complex rational. So complex meaning it's kind of complicated. So we're not going to graph it. If you want to, you can use a calculator to graph this one out here, and we're going to do so at the end of the video. But for right now, we're going to find the domain, and we are going to find the domain algebraically. Okay, this means with algebra. So we're going to do this with some algebra here. Okay? So what we're going to do is we're going to remember our domain and range rules here. And if you recall your domain and range rules, we have two of them. We have if it's a rational and if it is a radical. Okay? In this case, this problem here, it is actually both. I have a rational because x is on the bottom, and also I have a radical. So I'm going to use both rules here. So if it's a rational, you set the denominator not equal to 0. Okay? And for a radical, you set all terms in the radical greater than or equal to 0. Okay, so we're going to do that right now. So what we get is, this is my denominator, which means you're going to get two things here from this.
Students, all bathroom use must be done in the next 5 minutes prior to heading to your advisory. You will not be allowed to use the bathrooms at Nystrom during the movie, so take care of that now. Thank you.
So as you can see here, x squared minus 9 is not 0. And it is also going to be greater than or equal to 0. So if you combine these here, see, this one says it must be greater than or equal to, right? Because of the radical. Because it's on the bottom, it can't be 0. So this not equal to 0 takes off this equality here. So when you combine them, you get x squared minus 9 must be greater than 0. And this is a quadratic inequality. So we're going to use test points here. And we need our roots here, and our roots are at, when we set it to 0, we add 9. So x squared equals 9, square root, and don't forget plus or minus, so x equals plus or minus 3. So we put it at 3 and 3, and just test a point. Remember, you're going to test into here. Test into this one. I'm going to pick 0. If I put 0, remember these are my walls, if I put 0 here, you're going to get 0 minus 9 is greater than 0. That means negative 9 is greater than 0. This is clearly false, which means this is going to be true, false, true. And now we know, so we write this in interval notation, it's going to be from open dot. Negative infinity, so you want to, the answer is we're above the true, so it's negative infinity to 3 open dot. Why is it open? Because it is an open, there is no equality here, so it's just strictly greater than. So open here, 3 open to infinity, and so in interval notation this would be negative infinity to negative 3, parentheses, union, because of the space, 3 to infinity. And we're going to verify this with our calculator now. before the room gets too loud. So we're going to put this in. Make sure to put parentheses. It's x minus 2 divided by the square root of x squared minus 9. Right? It's minus 9, right? Okay, yeah. And now we're going to hit graph. And as you can see here, can't really see a lot, but just look. Just do the domain. Just find the domain. It goes from negative infinity to, where does it stop? Looks like about negative 3, right? Just as we predicted. And then it keeps going from 3 to infinity, just as we predicted. So this is our domain, and the answer is clearly B.